In this video, we're going to cover chemical equations, but before we get started, we're going to go back and review how to count the number of atoms in a chemical formula. It's important that you have that skill before we can move forward. So I'm going to give you a couple of examples. We'll start with something simple, water. A water molecule is shown in chemistry by writing H2O. This is its chemical formula. We know that it contains hydrogen and oxygen, and this subscript, the number 2, follows the element that it applies to. So in this case, we know that we have 2 atoms of hydrogen, and because there is no subscript here, it's automatically a 1 or a ghost 1 because we can't see it. That means we have 1 atom of oxygen. That's what a molecule of water looks like. What you may not be as familiar with is occasionally we will have a coefficient. A coefficient tells us that we have more than 1 molecule of that compound. Now we have 2 molecules of water. That also means that we no longer just have 2 hydrogen atoms and 1 oxygen atom. This coefficient gets applied to everything in the compound it comes in front of. So we multiply the coefficient by the subscript to learn the new number of atoms. So we have 2 times 2 gives us 4 hydrogen atoms, and 2 times that ghost 1 gives us 2 oxygen atoms. We'll try another one. In this case, we have H2CO3. This subscript tells us we have 2 hydrogen atoms. Because there's a ghost 1, we have 1 carbon atom. And here we have a subscript of 3 telling us we have 3 oxygen atoms. If for some reason there were a coefficient in front, we would have to multiply that coefficient throughout the compound. So we have 3 times 2 gives us now 6 hydrogen atoms. 3 times 1 gives us 3 carbons, and 3 times 3 gives us a total of 9 oxygens. Hopefully that refreshes your memory on how to count atoms. But now we're going to move on and actually take a look at a chemical equation. So in this case, we're going to use chemical formulas, but we're also going to show what happens in a chemical reaction. So this is what a chemical equation looks like, and really it's just shorthand for what happens in a chemical reaction. When we look on this side of the arrow, those are the things that we start with. The arrow shows us where the chemical reaction takes place, and the things on the right side show us what results from that chemical reaction. So on this side, we call all of these things on the left side of the arrow the reactant. And all of the things on the right-hand side are called the product, which makes sense because it is the end result. It's what comes out of the chemical reaction. It's also important that you understand that this is supposed to demonstrate the law of conservation of mass. The law of conservation of mass says that mass cannot be created or destroyed. It can only change form. So whatever you start with in a chemical reaction, you have to also end with, but it may look different. If you start with 17 carbon atoms, there will be 17 carbon atoms in the end, even if those carbon atoms are now in different formations with different compounds. You don't lose atoms or gain atoms in the process of a chemical reaction. So in order to determine if a chemical reaction shows that law of conservation of mass, we have to make sure that it is balanced. So we're going to take a look at how to determine if a chemical equation is balanced or unbalanced. In order to do that, when you first see a chemical equation, the very first thing you should do is draw a line to separate the reactant and the product. It gives you a visual representation of the 2 different sides. And then we're going to make a list of all of the elements that exist on both sides. On the reactant side, we have hydrogen, oxygen, and carbon. So I'm going to make my list. Over here, we have hydrogen, oxygen, and carbon, but we're going to make the list in the same order because it's going to be helpful later. Now we're going to count our number of atoms and total them up. Over here, we have hydrogen with that subscript of 2. So we know there's 2 hydrogen atoms. I'm going to write my 2 here. Now we have oxygen. We have 1 oxygen atom here, but we also have oxygen over here in this compound. So we have to make sure we add them together since they're on the same side. So we have 1 plus 2 gives us 3 oxygen atoms. And then we have 1 carbon because we have that ghost 1 or no number at all. Over here, when we find our hydrogen and its subscript of 2, it has 2 atoms. Oxygen has 3, and carbon has 1. So when we take a look, hydrogen, hydrogen, 2, oxygen, oxygen, 3, carbon, and carbon is 1. So this chemical equation does show us that the law of conservation of mass is in action, or this is a balanced equation. So there's nothing wrong with this equation. But we're going to take a look at another, because sometimes they don't work out quite like that. We're going to start with H2O, yields, that's how we read that arrow, yields or makes. H2 plus O2. Now remember, when you have a chemical equation, the very first thing you should do is separate the 2 sides, the reactant on the left and the product on the right. I'm going to draw my line and I'm going to make my list of elements. We have oxygen and we have hydrogen on both sides. On this side, we have 1 atom of oxygen because we have that ghost 1 as a subscript, and we have 2 atoms of hydrogen. Over here, we have 2 atoms of oxygen, and we have 2 of hydrogen. So now we're going to compare. Oxygen has 1 here and 2 here. Hydrogen has 2 and 2. So we have a problem. This chemical equation is telling us that we actually gained an atom of oxygen in the process of this chemical reaction, and that's not possible. So we call this an unbalanced equation. Your job is to make sure that you can figure out if something is balanced or not. Be careful to make sure that you look carefully at the subscripts and the coefficients, and that you look at the reactant and compare it to the product. Good luck.